Let's factor trinomials where a doesn't equal 1 using something called the reverse FOIL with AC method, also known as the Deaton method. Now what we're basically going to do is take the a times the c, which is 24. In case you're wondering, 3 times 8 is 24. We're going to find factors of 24 that give us 14. So let's see if we can list them. 1 and 24 won't give us 14. By the way, these are all positives. That doesn't work. 2 and 12. When we add those do give us positive 14, which is what we're looking for. That's our B. Now what we're going to do is take factors of A, which is 3, and list those in pairs. This is the only possibility we can have. So what that means is, in order for this to factor, this pair must divide into this pair with a 1-to-1 correspondence. In other words, if 3 divides into 12, that must mean that 1 divides into 2, which it does. Now we're ready to factor. We're doing the reverse FOIL, which means we're thinking what times what is 3x squared. Well, we already have our factors for a, so 1 and 3. I'm going to leave out the 1. So it'll be x times 3x, because x times 3x is 3x squared. And now, since I know what these are, and I know what these are actually our outers and inners, so I know that I got to find out what times 3x gives us one of these, and what times 1x gives us the other one. What we're going to do is we're going to use what we discussed earlier, saying that we know that 3 divides into 12, so 3 divides into 12 4 times. That goes in the other parentheses, and there is a 1 in front of the x, and 1 divides into 2 times, because when you FOIL it out, x times 2 is 2x, and 4 times 3x is 12x. These are actually the coefficients of the outers and inners. So what you're basically doing is using factors of a to divide into factors of AC to end up with the C. That's what we're doing. Let's do this next one. Let's take the a times the c, which is 12 times 5, which is 60. Now when you start listing factors of 60, you're eventually going to come to, well, let's just do it. 1 and 60. We need to get 19 when we add those. We don't get a 19. 2 and 30 won't work. 3 and 20 gives us 23, but not 19. 4 and 15 will work. Now what we got to do is find factors of 12 such that there's a 1-to-1 pair such that they divide evenly into 4 and 15. Start with 1 and 12. 12 won't divide into either one of those. That doesn't work. 2 and 6. 6 doesn't divide into either one of those. 3 and 4. When looky here, 3 goes into 15, 4 goes into 4. So what I've just found is these are the first terms, the first coefficients, 3x, 4x. Now I'm going to divide 3 into 15, and that goes 5 times. 4 goes into 4 once, and I'm finished. Let's try this next one. Let's take 30 times 4, which is 120. Find factors of 120. When you do that, you're eventually going to come up with 6 and 20. Now notice we need a positive 120. At the same time when we add, we need a negative 26. That means both of those must be negative. Now let's list factors of 30. See if we can find a pair that divides into 6 and 20, or negative 6 and 20 I should say. See, 1 and 15. 15 won't go into either one of those. 1 and 30 I meant. 30 won't divide into either one of those. 2 and 15. 15 won't divide into either one of those. 3 and 10. 3 will go into 6, 10 will go into 20. So that's one possibility. Let's just keep on going. 4, what doesn't divide? 5 and 6. Uh-oh. 5 divides into 20, 6 divides into 6. You know what that means? So there's something wrong. What that means is there's a GCF that should have been taken out in the original problem. So here we go. We're going to have to redo this problem. We're going to take out the GCF, the greatest common factor. So you look at 30, 26, and 4, they're all divisible by 2. So let's divide each of those by 2, and that goes inside the parentheses. And it's going to be a new polynomial we're going to have to factor using the same method. So the 2 is going to stay, that's our GCF. We're going to end up with 2 binomials. So let's do that inside parentheses using this reverse FOIL with AC. 15 times 2 is 30. Factors of 30 that gives us negative 13 would be negative 15 and positive 2. Nope, you would think that, but notice we got to have a positive 30 when you multiply, that doesn't give you a positive 30. So that doesn't work. How about negative 3 and negative 10? That will work. So just because the numbers work out, gotta check the signs also. And now, let's take factors of 15, and that divide into both 3 and 10. Let's see, 1 and 15, neither one of those will work. 15 won't divide into either one of those. 3 and 5. 3 goes into 3, 5 goes into 10. There we go. So these are our coefficients for our first terms. So we're going to write it as 3x and 5x, because 3x times 5x is 15x squared. So now let's divide 3 into negative 3, and we get negative 1. 5 into negative 10, and we get negative 2. If you pull it out, you'll see that it all checks out the way it's supposed to. So this last one, we have 6 times negative 5, which is negative 30, because that's our A and that's our C. Let's find factors. It's negative 30. I didn't put that minus sign in. I should have. Find factors of negative 30 that gives negative 7. When you think about it, do it all, you'll end up with negative 10 and positive 3. Because negative 10 times 3 is negative 30. Negative 10 plus 3 is negative 7. So now, I need to find factors of 6, such that there's a one-to-one pairing that divides into these factors. So 1 and 6. 6 won't divide into either one of those. 2 and 3. 3 divides into 3. 2 divides into negative 10. So there we go. We know what our first terms are. 2x and 3x. Now 2 divides into negative 10, negative 5. 3 divides into 3, positive 1. Only thing left that we have to consider is, and watch this, is the y squared on the end. Y times what is y squared? Y times y. So if you want to check these, you pull it out. 2x times 3x is 6x squared. 2x times negative 5y is negative 10xy. 1y times 3x is positive 3xy. Negative 10xy, positive 3xy gives us negative 7xy. And 1y times negative 5y is negative 5y squared. Checks out, and we are done. 30y squared. Poop.